Have you ever wondered why the ocean is salty, while the rivers that flow into it are fresh? This question may have crossed your mind as you stood on a sandy beach, gazing out at the vast expanse of the sea. Or perhaps it struck you when you heard an intriguing tale, such as that of sailors Judith Masso and Kevin Hyde. These intrepid explorers set out on a sailing journey from North Carolina to Florida in late 2022, only to be caught in a brutal storm that left them stranded in the middle of the ocean for 10 long days. Surrounded by an endless vista of water, their predicament was paradoxically exacerbated by the very element that seemed so abundant. The ocean water, as vast as it was unfit for consumption due to its salinity. This tale brings us to the question at hand. Why is the ocean salty even though the rivers that flow into it are fresh? The answer lies in the intricate dance of Earth's hydrological cycle and geological process. Covering around 71% of the Earth's surface, water is a predominant feature of our planet. However, not all water is created equal. Almost 97.2% of it is salty seawater, while a minuscule fraction, less than 3%, is freshwater. This division is a key to understanding the origins of ocean salinity. From the early days of Earth's formation, water likely started as a relatively pristine substance with low levels of salinity. Over millions of years, however, a combination of geological phenomena and environmental factors led to the accumulation of salts and minerals in the oceans. The water cycle, a fundamental process in Earth's climate system, plays a pivotal role in this transformation, involving the continuous movement of water between the atmosphere, land, and oceans. The difference between fresh river water and salty ocean water is a fascinating tale of Earth's geological and environmental processes. It speaks volumes about the dynamic interplay between the Earth's geology, climate, and hydrology. As we continue to unravel this salty mystery, we come to appreciate the intricate dynamics of Earth's water systems and the vital role of our precious freshwater resources. Rainwater starts as fresh water, so how does it become salty by the time it reaches the ocean, you might ask? Well, the answer lies in the intricate dance of Earth's hydrological cycle and geological processes. Let's start with the water cycle, the continuous movement of water on, above, and below the surface of the Earth. It's a fascinating process that involves evaporation, condensation, precipitation, and runoff. When water evaporates from the Earth's surface, it rises into the atmosphere, cools down, and condenses to form clouds. Eventually, this condensed water falls back to Earth as rain, sleet, or snow, collectively known as precipitation. This is where things start to get salty. As rainwater falls on the Earth's surface, it doesn't just soak into the ground or flow straight into rivers and streams. Instead, it spends some time interacting with the environment, and this is a key part of our story. The rainwater, in its journey over and through the ground, acts like a miniature mobile water treatment plant. As it moves, it erodes rocks and soil, dissolving a variety of minerals along its path. These minerals include salts like sodium and chloride, which are the main components of sea salt. This mineral-rich water then flows into rivers and streams, carrying its cargo of dissolved salts and other minerals with it. But here's the catch. While the water is in motion, its salinity or salt content remains relatively low. After all, it's constantly being refreshed by new, clean rainfall, and the dissolved minerals are spread out over a large volume of water. However, the story changes when this mineral-rich water reaches the ocean. Here, the water slows down and the salts have time to accumulate. Over time, as more and more mineral-laden water flows into the ocean, the concentration of salts in the ocean increases. And that, in essence, is how rainwater, which starts out as freshwater, becomes salty by the time it reaches the ocean. Once the mineral-rich water reaches the ocean, the salts accumulate, leading to increased salinity. It's a fascinating tale of science and nature, isn't it? Volcanoes contribute more to ocean salinity than you might think. These fiery giants are not just a spectacle of nature's power, but also a vital part of Earth's geological processes. When a volcano erupts, it releases a cocktail of gases and minerals into the atmosphere. These substances, carried by winds and eventually deposited by rain, find their way into our oceans, adding to their salt content. But the influence of volcanoes extends even beneath the waves. Hydrothermal vents, essentially underwater volcanoes, spew out hot, mineral-rich fluids. These substances mix with the surrounding seawater, further enhancing its salinity. So volcanoes, both above and below the water, serve as an active conveyor belt, moving minerals from the Earth's interior to the ocean. Over millions of years, this steady supply of salts and minerals, combined with those from weathering rocks on land, has contributed significantly to the salinity of our oceans. The cumulative effect of these processes over millions of years has resulted in today's salty seas.